Hello everyone and welcome to the VivoQuant 3.0 release webinar. My name is TJ Ligori. I'm a software account manager for InVicro, and today I'll be going through the very exciting and much anticipated release of VivoQuant version 3.0. A little outline and background before we get started. So today I'm going to start off taking you through some slides just briefly on the background of InVicro, just a quick overview of who we are, what we do. Then I'll introduce some of the features and tools that we'll be reviewing in the software, and then wrap up naturally with a review of the software itself, going through the new features and of course highlighting some of the old features as well. Now, if at any point during the presentation you have a question, feel free to post that in the questions box in your GoToWebinar app, and I'll answer those at the end. Or, of course, you can hold on to them and ask them at the end as well. Great. So let's get started. As I mentioned, just a quick background on InVicro. We were founded in 2008. Primarily, our focus is on imaging informatics. Anything that has an image, we're interested in it. And as far as we're concerned, an image is just an array of numbers. So it can be a picture or a SPECT image or a CT, doesn't matter. If it's got numbers, we're interested. We launched the iPACs and VivoQuant software products in 2009 as a way to help support our customers that were already working with us in our services businesses, being the image analysis and contract research. And then subsequently opened up our own imaging facility here in Boston, where I'm sitting right now, as well as at partner sites across the country, as well as internationally, with headquarters in London as well. Q1 of this year, 2016, we also joined forces with M&I, Molecular Neuroimaging, based out of New Haven, Connecticut, which really expanded our offerings from the preclinical space into the clinical space, so we can truly offer solutions from target identification through clinical trial. Our Boston headquarters, I'm currently sitting just inside this window here on the 6th floor. Our New Haven headquarters, as I mentioned, we merged with at the beginning of this year, the Translational Imaging Center in Michigan, and then our imaging lab in London at Queen Mary University. We have over 200 total staff, over 150 of which are performing research on a day-to-day basis, primarily, as it says here, with backgrounds in medicine, chemistry, biology, etc. But at the end of the day, our goal is to be an imaging solutions provider for the market, both in pharma and academia. As I mentioned, with the acquisition of M&I at the beginning of the year, what we've really now been able to do is extend our services from target identification through phase 3 trials in a number of different applications. We don't really care, to be completely honest, about the application of a drug so much as we care about being able to perform the analysis and manage that study for you, and of course provide the software necessary to do so as well. So as I mentioned, we have a variety of divisions: preclinical, translational, clinical, all of which are really supported by our software, chemistry, and analysis groups. And of course today we're primarily interested in talking about the software. So diving into the software team a little bit, as I mentioned before, we have over 8 years experience designing, implementing, and maintaining software. We have 2 software platforms: the VivoQuant, which of course you're all here to talk about today, and the iPACs, which is our data management, storage, and reporting tool. And together they truly provide an A to Z solution for all of your imaging needs. Currently they're being used, either VivoQuant, the iPACs, or both, in over 180 laboratories worldwide, including over 70% of the top pharmaceutical companies, and really providing an enterprise-grade solution for your data management, reporting, visualization, and analysis needs. So diving into VivoQuant, and in particular VivoQuant 3.0, we've had a very exciting development cycle for VivoQuant 3.0 with a lot of great new tools entering the fold, as well as just expanding on some old tools. So primarily in VivoQuant 3.0, we wanted to focus our emphasis on some translatability, some additional clinical tools, and a lot of work was put into managing dynamic data in the software. Can't speak enough to the amount of effort that was put into our expanded modeling capabilities. We've added 4 new models with this release, as well as parent fraction modeling, plasma and whole blood modeling, microparameter fixation, so fixing K1, K2, whatever the user wants, as well as enhanced plotting, which we'll take a look at later, and also adding time stability analysis into the tool. And of course, along with all of this, and I really can't emphasize enough that everything that we cover today is also accessible to our VivoScript platform. So that includes our modeling tool, as well as our new ECRF, electronic case report forms, that we've added this release cycle. We've added a flexible data selector for easier interaction with dynamic data, and we'll go in pretty deeply into how that works. We've added some additional quantitative metrics into the 3D ROI tool, so some more statistically relevant values that you might be interested in. And finally, one that's very interesting and exciting is we've updated our capabilities for image windowing in terms of how we interact with the color palettes and viewing the image window. So we're very excited about that. So jumping into the software itself, just a quick overview. I'm going to go through essentially 3 different workflows with 3 different really types of data, or 3 different data sets. The first being a fairly basic workflow of loading and pre-processing data and then ultimately quantifying it in our 3D ROI tool. The second, a more clinically focused workflow, although fully supported with preclinical data as well, using those ECRF forms that I mentioned. And then finally, a deep dive into the modeling tool, going through getting your plasma curves set up, as well as modeling using various models, and how we can take that information and pull it out of the software and make use of it. So here I'm going to load some data from an IPACS platform. For those who are not familiar with the IPACS, I mentioned before, it is a data management and reporting solution that we produce, and it speaks directly with VivoQuant for sort of seamless data loading. Of course, we also support loading a number of data formats locally, just from your computer, whether that's DICOM or non-DICOM. We support, I believe there's over 18 different image formats currently, and that number is always growing. Really, any time a new format comes out, we try to adopt it as quickly as we can. So here I've loaded a SPECT-CT dataset, and there's a few things you'll notice right away when we look at it. The data is not well registered. We might have some windowing issues in terms of how we're viewing the data. VivoQuant can handle all of these. Now, for those of you who remember from VivoQuant 2.5, here on the left we have our data list, which also displays a color palette for each of the loaded frames. And we can adjust how the data look on the screen by adjusting that min-max. We can pull down the color bar, pull it up from the bottom to hide various voxel intensities. Now, that's great. However, one thing that we've now added is additional controls to that. So sometimes maybe you don't want to be looking at the data list, but still want to adjust how that data look and feel on the screen. So what we've added now are essentially right-click controls. So if we right-click in the image and drag down, the image, as you see, will become brighter. We're essentially pulling the color palette down. Or the opposite, we can go up from the bottom to make it dimmer. We can also go left to right, essentially pulling the bottom of the color palette up, hiding those low intensity values. We've also extended this beyond just our traditional min and max representation of the color palette. So you'll notice now in our configuration, we've added the ability to view not only data using a min-max paradigm, but also using the window level, window width, sort of similar to how your traditional clinical viewers operate, where we can adjust the width of the color of the windowing, and then also adjust the level by sliding this back and forth. You can still use essentially the same tool in terms of just adjusting one end of this as you would with the min-max. If you hold Shift and click, the ends freeze and drag similarly to in our min-max. And here also we have the right-click options. If I right-click and pull down, my window width will grow and shrink. Left and right, I'll be sliding that level. So just trying here to make it a little bit easier to interact with your data in a way that's as easy and seamless as possible as you're moving through the software. Now with this data set, it is dynamic, as I mentioned, so we have a lot of different frames and we're going to want to register them all to the CT. So the way I like to do that is first to make an average of all of the frames, or all of the spec frames, I should say. So we do that in the arithmetics tool. Now, many of you might remember in the arithmetics tool, in the past, it's been very difficult to choose which data you want to interact with, which data you want to work with. So what we've done is we've added this flexible data selector. So rather than just being able to select your reference image, input 1 or input 2, you now have access to any combination of the frames. So here we can type, say we are interested only in working with frames 4 through 6. We can do that, and you'll notice in this drop-down now 4 through 6 have been selected. We could also select, maybe we only want to look at the odd frames, right? Maybe we only want to average those. We can average 1, 3, and 5. And if we look here, 1, 3, and 5 have now been selected. We can also mix these up. So for instance, maybe 1 and 3 through 6. And you'll notice that as we interact with the text box and the widget, the two update simultaneously. Now here we want to average everything but the CT. So let's click all and then uncheck the ref. So now what we're going to do is average frames 1 through 6 and append that average to the end of our data list. Now we go to the end of the data list, and there we have the average. I can move it to input 1. Previously, we only had swap options. We've added these move options now in 3.0. So now when I look at my data, I'm looking at the CT as well as an average of my spec frames. So I can use that now to drive my co-registration, which in this case, I'll just do manually. I think many of you are familiar with our automated tools already. And again, here we have that same data selector. And once again, I want to move everything but the CT. Great. So we've manually co-registered my spec to my CT using that average image as the driver. I can apply this co-registration. And again, I'm applying this to all of the spec frames. And then unload this average image because we don't want to actually quantify it. Next step here might be to perform some cropping. Nothing's changed here in the cropping operator, just a reminder. Essentially what you see is what you get. We just grab the edges of the image and drag them in around the area that we want to crop and click check, and the entire image will be cropped all together. Now from here, we've pre-processed our data, co-registered it. The final thing now would be to draw some ROIs and do some quantification. So I'm not going to go too much into the tools in the 3D ROI tool. However, one thing that I will point out is, as I mentioned, we've added new things you can quantify. So essentially new columns to our quantification table. That said, these are flexible. So here under the operator dropdown, we have this list of quantification table list, and really similar to the data selector that I showed you a minute ago, we can choose what we want to actually report on when we quantify an ROI. For instance, we've added these new concentration metrics, the concentration of the 10% brightest voxels within a region, or the 50% of the brightest voxels in the region. Also, the peak region and peak max, which are essentially small 3x3x3 matrices that surround either the brightest voxel within a region or the brightest 3x3x3 region within the ROI. And that's explained a little bit more clearly. There's some images to help you out in the help guide. So in this case, let's keep all of these checked, but I could always uncheck something if I was not interested, such as maybe I don't care about these new concentration columns. I'm just happy with how things were reported previously. I can uncheck those and then they won't be calculated. For now, let's keep those on. And I'll just quickly draw sort of a whole brain ROI. So nothing new here, same 3D ROI tools. I'm just manually drawing sort of a quick ROI in the brain just to show some of those quantification tools sort of in action. Great, so I have a pretty rough whole brain ROI here. And now when I click my Show Table button, you'll notice it takes a little bit longer to calculate now, right? We have a lot more things that we're looking at, but we have still the measurements for all of the loaded frames. And now for each ROI, as I mentioned, we have that conc 10%, conc 50%, peak region, peak max, etc., all available. And when you upload these ROIs to the IPACs, those measurements now become accessible to the IPACs reporting tool. So it's sort of an immediate availability in terms of the reporting. One thing I will point out here in the 3D ROI tool, again, not something that's new or different, just something that I think is important to emphasize, is storing ROIs. So one thing that VivoQuant does very nicely is keep track of your data. So here we can store these ROIs directly as they are to a local location on your computer. For instance, here, if I want to name this whole brain, I can do that. Now, the advantage of storing ROIs separately from the data itself is that you can use the same ROI for multiple data sets. They're not necessarily linked in a permanent fashion. So I can open up a new data set, open up this whole brain ROI, adjust it, and be ready to go for the next data set, Of course, in those cases, you'd still probably want to save your final ROI on a per data set basis. Of course, using the IPACs, this is also very easy, as we can store these ROIs directly to the IPACs associated with the loaded data. And you'll also notice that has gotten a bit faster than it was in the past. So we've improved our efficiencies in terms of uploading ROIs to the IPACs, particularly for large dynamic data sets or ROIs that have a lot of regions. We've made the transfer much more efficient. Okay, so that's more or less your standard workflow. Of course, we still have our general tools such as image saving, making a MIP, saving a movie, things like that. These things really haven't changed. Of course, we can always pull up a MIP just because they're fun to look at, maybe without the ROI or with it. Again, that's a pretty lumpy ROI, as I did just draw it pretty quickly, but just to give you that visual effect. So as I mentioned, those things really haven't changed. One thing that has changed, though, as I mentioned before, is we've really grown our clinical offerings. So starting out with the ECRF module. So This is a tool that works really in conjunction with the IPACs. So I'm going to just quickly go to my IPACs here. Just to show you what I'm talking about. So here we have in the IPACs flexible forms. Those of you who have the IPACs are fairly familiar with these. One of these forms now is called the ECRF list, which essentially is a tool to tell VivoQuant what form is important for a given project. So for instance, if I load this data set here, spec.ct, from that same project, here we have the data, great, everything looks good, but maybe I want to provide some more feedback to the IPACs or to another user who wants to look at this data. These forms are fully flexible, so they can be really primarily used for QC of image data, but can also be included in QC of, say, regions of interest. If you have a large team drawing regions and want one person to review them, it would be fairly straightforward to write up a form to review these ROIs and provide feedback. So here what we'll do is create a new form. It knows what project the data came from, and I can specify which of the loaded data sets I want to submit a form for. We also have an advanced tab, so if there was a different form that you wanted to use other than the one in those drop-downs, you could do that, or even change what level you are submitting that data point to, whether that's the image level, series level, study level, or project level. But for now, let's just go with the basics. So I get this form that opens in the software. Now this form, as I mentioned, is editable on the IPAC side. So anything that you, as a user, want to be able to track on the IPACs in one of these forms, you can build that and then just have another user fill this out, is the general idea. So in this case, let's just fill it out pretty quickly. We're going to say there's no artifacts. We're going to say that everything looks good. If I say yes to this artifacts, one thing that we can build in these forms are conditional statements. So for instance, if this says yes, I'm forced to fill out this comment field. So let's just do that. Lots of artifacts. And I can require an electronic signature. So as a user who's filling this out, I have to provide my login credentials and submit. This data point was submitted now to the IPACs. So if I go back into the IPACs and click here, you can see here's my information that I just reported. And then, of course, this becomes available to the IPACs reporting engine. So another example of sort of the seamless interaction between the two platforms, but also something that can be very, very useful if there's many users that are going to be reviewing the same data. And as I mentioned before as well, the ECRF module is available to the VivoScript platform. So a script could easily be written to cycle through every data set on a project, load the data, set your min-max or your window level, window width, if you will, as expected, maybe open up an ROI, and then open the ECRF form so that the user can fill that out, click OK, and then cycle to the next data set. So while this was built with a clinical focus in mind for radiology reads, it could also be a very strong tool for just building in your own QC pipelines. Now kind of moving on to the third, final, and what I think is the most exciting workflow that we've really fleshed out in VivoQuant 3.0 is the updated modeling tool. So many of you might remember we did release the modeling package upgrade in VivoQuant 2.5. It was a big step from previous versions. A little history, we started with 3 models and really not a lot of convenience functions. And then in 2.5, we added some additional models that the user can interact with. And now, really, we've built this tool out to the point where I think it's going to really handle about 80 to 90% of your modeling use cases, including, as I mentioned before, editing or smoothing blood curves, fitting blood curves, exporting information that you need, including information criterion, AIC, BIC, etc. So here, let's just load some ROIs for modeling, which are already available on the IPACs. And one of the hurdles with modeling data, of course, is identifying the frame times, so the start time and duration of each frame. This is particularly difficult in the preclinical space, given that sometimes we don't have this information in the header, or sometimes we have to make changes to it, or if we've, in the clinical space, maybe we're combining 2 imaging sessions and need to be able to keep track of that information. So something that we've added sort of to the general tool, not necessarily in the modeling tool, is a frame time editor. So here, this is just a flexible form that allows a user to put in acquisition times, frame durations for each loaded frame. And one other thing I'll point out is that, as you see in this case, it will try to read from the header. So if it can find this information, all the better. But if not, you can copy and paste. So for instance, I could copy this table and paste it directly into Excel to make changes, and then also copy and paste out of Excel back into the software. It also has convenience functions for computing frame durations or acquisition times based on the other columns. So one thing here is we are assuming a continuous acquisition. So if the patient got up and then we imaged again, this wouldn't necessarily handle that case. However, very powerful if all we have is the acquisition time or the frame duration. You can sort of piece together the rest of the way. And one of the reasons that we put that into the general tool as opposed to into the modeling operator was so that we could then apply it to plots in the 3D ROI tool. So here, this data set has a lot of regions, so this might take a second to calculate, but essentially now what we've done, if you remember from 2.5, we could plot time activity curves directly in the 3D ROI tool. This is still the case. However, one complaint that we had heard a lot from customers was that the x-axis of those time activity curves were not relative to time. They were just relative to frame numbers. So the time activity curve could essentially become very misleading. And so what we've done is we've now added this frame time editor for the dynamic data. And if we have that information in the frame time editor, when we go to plot the data, it will include that. So the time activity curves will be more useful and more sort of presentation ready, or even just assessment ready without having to sort of redetermine what everything is. So for instance, in this case, maybe we're interested in the mean signal in each region as a function of time. We can plot that, and you see now here on the x-axis we have our acquisition time. These time activity curves look much more realistic, obviously. And here we've also updated just the view of the plots. It's a little bit nicer here. We're linking the colors to the color of the ROI itself. You can scroll through the legend, things like that. All sort of built off of improvements that we made in the modeling tool, which I'll get to next. And of course, you can save that plot as well locally to your computer, as always. So jumping into the modeling tool, as I mentioned, one of the big hurdles was including blood modeling. So now we've essentially added 3 ways of getting your input function. So the first, if you have that information in a spreadsheet, for instance here, maybe from blood draws or some other method, we can copy and paste directly into VivoQuant. So you see here we have the blood concentrations. We can specify what units those concentrations are in, and we have a fairly extensive list for doing that. Then we can estimate a start time. The reason to do this being that usually you're going to have a ramp up and then a wash out. So we can essentially estimate at what point to begin the modeling, so the peak of that curve. And when we run that fit, here you see we're fitting to a exponential, linearly interpolating up to that start time, and then fitting the curve from there. Now we can take this curve and we can save the fit, or save just a linear interpolation between the points if we think that's more reasonable. In this case, let's name this curve from spreadsheet, just so we don't get confused. And that now becomes available to us within this instance of VivoQuant. Now, we can store this curve, again, locally to the disk or to the IPACs associated with the loaded data, which then would allow us to bring it back in and use it in another instance of VivoQuant. But currently, as I just did it, I would only have this curve for now, and I would lose it upon closing the software. So a good idea to save this as we go. That said, we can also save and load curves from the IPACs or from the disk. So here I can load from the IPACs. I already had a curve stored for this data set. And one of the reasons that this is very powerful, in my opinion, is for running multiple modeling routines on the same data set. We can save that curve once to the IPACs and then pull it down subsequently for additional iterations of the tool, which is very powerful given the availability of the VivoScript platform. The third way to get your curve, your plasma curve, of course, is to do an image-derived input function. So, for instance, maybe if we wanted to use the cerebellum as our input function, we can compute the concentrations at each frame from the cerebellum. Again, estimate that T0 and run. Here we get a very different curve. So maybe this is the one we would want to use. Maybe we're going to run a reference tissue model like SRTM or MRTM. So again, let's save this. We'll call it cerebellum. Great. Now we can get into some modeling. Now, of course, one other piece there that I failed to mention was we can adjust what frames get used. So if we look at that curve and say, I really think the curve at 11 minutes or so is an outlier. I think maybe the point is way off in the distance. It doesn't fit the curve. That's no problem. We can just go to that point. Here we go, 12.5 minutes. Run again, and now you'll see that point's missing. We've interpolated without it and computed. So taking care of any noise properties that you might have. Likely more useful with an arterial input function, but can also be used really across the board. And of course, you can use that also when you're performing your modeling. So for instance, let's take a look at a two-tissue compartment model on this loaded data. So a few things to speak to before we even run the model, some settings that you can adjust before you get started. So here we have these two theta values. If you hover over them, they'll tell you what they are. But essentially, these are your boundary conditions for computing your model fits. We do use a basis function approach for the two-tissue compartment as well as the one-tissue compartment models. So these sort of just play into that. We can adjust the weighting parameters of how the fit will be calculated. In this case, we're just going to do a uniform weighting across the time points, but we could also take into account isotope decay or frame counts. Of course, our input function, in this case, let's go with the plasma curve from the IPACs. We can use a whole blood curve if we have one. In this case, we don't. If we do, we would also want to put in a blood volume. And then here, again, we can adjust the lower bound and upper bound of our micro parameters, K1 through K4, or we can choose to fit those values. So for instance, if I want to run my two-tissue compartment model with non-displaceable binding, I can set my K4 equal to 0 before I run the model and know that that the K4 will be set to 0 for when I'm computing the fit. for now, let's choose to fit all of these conditions. I'll read my frame times from the header or from the frame time editor. And here I'm going to run the modeling on the ROI level. I could run it on the voxel level to get a parametric map, but in this case, I think I'm going to stick to the ROI and click Run. Here it's going to model the two-tissue compartment model for each region and bring up the plot. Now here I can go through different regions and see that plot. I can also look at some of the newer plotting functions, newer plotting tools, such as viewing an overlay of all of the regions, or I can choose, sort of similarly to that flexible data selector, I can choose to just look at a few of the regions. So I can choose, you know, I'm really interested in my striata and my angular or my amygdala, for instance, and I can view just those plots overlaid. And I can pick any number of these up to, well, all of them. Going down the list here, I also have a bar chart, so I can, which is a different way of viewing the same information. So what I see right here, looking at the VT, the striata, my pallidum, and my NAC are all showing very high VT. And I can also choose to look at some of this information down here at the bottom, being all of my criteria that were fit, as well as my information criteria, my AIC and my BIC, really giving me information about how good this model fit really is. And of course, kind of at the end of the day, we're going to care about getting all this out of VivoQuant. So we have 3 different types of save buttons. The first here, going left to right, save plot. We'll save just this one individual plot. We'll just call it plot 1 for now. And that saves just into my folder. I can also save a spreadsheet of all of my information. So we'll call this spreadsheet. What that will do is save a spreadsheet with the fit criteria, as well as, and then a subsequent spreadsheet with the essentially the time activity curve and the modeled time activity curve. And then the last one, the save all ROI plots. I'm not going to do this, but just trust me, it cycles through all of these ROIs and saves a PNG for each of them in the selected folder. The one more pretty cool feature that we added into the modeling operator that was requested by a number of users was the time stability analysis. So for this, just for speed purposes, I'm going to use a reference tissue model and our cerebellum curve that we created earlier. And I'm going to go under Operator, Time Stability Analysis. So here, essentially what we're doing, for those who maybe don't have as much of a background in the modeling, is we perform the modeling for each ROI with a different selection of the time points included, essentially to determine how long we needed to model to get a stable result. And as you can see here in our time stability plots, we can go through different outputs from this model. In this case, maybe even look at some of the information criterion and see what's going on there, or some of our macro parameters. And again, we have the ability to choose looking at certain ROIs or all ROIs. And in this case, it looks like we leveled out pretty quickly, so that's good news. We certainly imaged it for a long enough period of time. And that will just inform your modeling or your acquisition parameters for moving forward. The last thing I'll say about the modeling operator, and I know I've mentioned it before, but I truly can't say it enough, is that all of this is fully scriptable. It's fully script ready. So for instance, you could very easily write a script or a series of scripts to perform each model with various functions or various settings and output those results, and even in that script upload those results to the IPACs. This is all fully integrated with the IPACs for data mining and reporting. So really with that, I would like to open up the floor to some questions. And before I do that, also just a bit of a shameless plug in terms of where you can find us for more help. Take a look at invicro.com, our YouTube page, which this webinar will be posted on shortly. Our blog, blog.invicro.com. We post a lot there on pretty novel uses of the software, from scripting to reporting, you name it. And then, of course, you can always reach us at support@invicro.com. So we did have a couple of questions, or one question in the chat regarding clinical approval. So VivoQuant can be used for clinical analysis. You would need to perform your own internal validation of your workflows. It's not, however, approved for diagnostic purposes, strictly for research. And, oh, another one, when will VivoQuant 3.0 be available? It's available currently on VivoQuant.com, as well as within your current installations of VivoQuant. If you go to Tools Update Check, it will recognize that your version is out of date and allow you to download and install the new version. Are there any other questions from the audience? If so, please post them in the questions box on in your GoToWebinar app. Okay. Oh, one more. Can I show voxel-wise modeling on the current data? Absolutely. So one note I'll make is that the voxel-wise modeling naturally takes a bit more time than the ROI or the per ROI modeling. So what I'll actually do here, and let's go with I'm going to stick with the MRTM. So this might take it a little bit longer, but as I mentioned, at the end of the day, this will be a very nice parametric map of actually in this case, the entire image, because I chose not to mask it. And then you can even generate a 3D rendering of that model parametric map, or you could even, you can create images. Whatever you really want to do with that can be done once that finishes. This might take a minute, so if there's any other questions, certainly feel free to post them now. So another question, how well does VivoQuant 3.0 work with external DICOM servers? So it works very nicely in terms of opening and posting data to external DICOM servers. It can serve as a DICOM node, so the data transfer can be fairly seamless. One note I'll just make there is that most other DICOM servers don't have the ability to handle things like the ROI data points or things like that I was mentioning before. So here the fitting finished. I can click on any voxel now within the image and see essentially the model fit at that point. And then I can also prepend now my parametric map. If we go to the data manager, you'll see, let's just adjust my windowing here. Might want to increase that width a little bit. There we go. So here we're looking at that first parameter. We can view it in 3D even with the ROIs overlaid. That's just calculating. And then you could even run some statistics from the 3DRI tool on the parametric maps if you wanted, or just use it for generating images. Great. So if there's no more questions from the audience, I hope you all have a wonderful day. As I mentioned, please check out the additional help tools available online. And as always, thanks for calling in, and we will talk to you all soon.